Assalamualaikum and hi everyone. Today we are going to learn on the derivative of logarithmic functions. The learning outcomes of today's lesson is to differentiate natural logarithmic function or denoted as ln x, ln x. Now we look into the derivative of natural logarithmic functions. If we differentiate ln x, we will get 1 over x. But if we differentiate ln fx, okay, by using the chain rule, we will get it as 1 over fx multiplied with f prime x. So if you notice here, differentiate ln fx, it will follow the differentiation for ln x, okay? So ln x, differentiate, we get 1 over x. If ln fx, we just replace x with fx and times with f prime x. So towards the end, we get it as differentiate ln fx becomes 1 over fx multiplied with f prime x. Okay, now we look at the first example. Okay, we want to find the dy dx for y is equal to ln x powers of 3. So if you can look at here, okay, ln x powers of 3, it is in the family of ln fx, alright, where the fx is equal to x cubic. Okay, it is in the family of ln fx where fx is equal to x cubic. Alright, if you want to differentiate ln fx, okay, we have discussed in the previous slide, it is equal to 1 over fx times f prime x. So we need to find the f prime x. So the f prime x is given 3x squared, we differentiate x cubic. So now if you want to find the dy dx, so it becomes, okay, 1 over fx, 1 over x powers of 3, differentiate fx, okay, differentiate x cubic, okay, we will get it as 3x squared. So we will get 1 over x powers of 3 times with f prime x, 3x squared. So we get it as 3 over x after we simplify the expression. Now we go to the second example. Let's say we have y is equal to ln 2x squared plus cos x. Alright, so if you look at this one, similarly, okay, the y, it is in the family of ln fx because we have the question ln something, ln 2x squared plus cos x, alright, with the fx is 2x squared plus cos x. And similarly, alright, the equation, the y, it is in the family of ln fx, so therefore we differentiate ln fx, we will get 1 over fx times f prime x. And the f prime x, okay, differentiate fx, we get 4x, differentiate cos x, we will get negative sine x. Okay, now if we replace fx and f prime x, so we get 1 over 2x squared plus cos x, and this is the differentiation for f prime x. So if we differentiate f prime x, okay, if we differentiate fx, we will get f prime x as 4x minus sine x. Okay, 1 over 2x squared plus cos x multiplied with 4x minus sine x. Or we can also write it as 4x minus sine x divided by 2x squared plus cos x. Now we move to the third example. Okay, we have y is equal to ln x sine x. If you look at this one, ln x sine x, okay, if we use the logarithmic properties, we can use these properties. Okay, if we have ln a times b, we can write it as ln a plus ln b. So here we are going to use these logarithmic properties to solve the dy dx for this case. Alright, so therefore, if we use the logarithmic properties, we can write y is equal to ln x plus ln sine x. Okay, so we are going to differentiate that. Differentiate ln x, we'll get this one, 1 over x. Differentiate sine x, so we have to use the 1 over fx times f prime x. So we get 1 over sine x. Differentiate sine x, we'll get cos x. Alright, so towards the end, we will get 1 over x plus cos x over sine x, or also 1 over x plus cotangent x, because cos x over sine x is cotangent x. Okay, next example. Okay, we have y is equal to ln x plus 3 divided by 3 minus x. So if you look at this one, okay, if we follow the logarithmic properties, okay, we can use this formula. We have log properties, ln A over B, it is equal to ln A minus ln B. So if we write back y, we can write ln y is equal to ln x plus 2 minus ln 3 minus x. So we are going to differentiate this one. Alright, so if you differentiate that one, okay, by using the ln fx differentiation, we get 1 over fx times f prime x. So we are going to differentiate it one by one. Differentiate ln x plus 2, we get 1 over x plus 2. Differentiate x plus 2 minus differentiate ln 3, 1 3 minus x, 1 over 3 minus x, and multiply with differentiation for 3 minus x. So we get here 1 over x, differentiate x plus 2, we get 1 minus 1 over 3 minus x, differentiate 3 minus x, we get negative 1. Alright, so if we write back, we can write as 1 over x plus 2 plus 1 over 3 minus x. Or if we simplify, towards the end, we can write it as negative 5 over x plus 2 multiplied with x minus 3. Okay, next example. Okay, we have y is equal to x squared ln sin x. Okay, we have this one. Alright, so if you look at this one, y is equal to x squared ln sin x. It is sin x. It is a product between two functions, function x squared and ln sin x. Okay, so we assume we need to use the product rule here because in general the question it is a product between x squared and ln sin x. So here, okay, so we need to use the uv. Alright, so u is the x squared and v is the ln sin x, and the u prime is 2x. Okay, differentiate cos x, will get 1 over sin x multiplied with cos x. Okay, so now we need to use the product rule because the y it is in the product rule form. Product between two functions. So we use from the uv prime plus vu prime. After that, we substitute the value for u, v, u prime, and so on. So therefore, we get u is x squared. V prime is 1 over sin x multiplied with cos x plus v is ln sin x and u prime is 2x. Okay, since cos x over sin x is cotangent x, so we can simplify it as x squared cotangent x plus 2x ln sin x. Okay, here actually we can also take out the factor for x. Alright, so maybe we can write x bracket x cotangent x plus 2 ln sin x. Okay, now here are some of the questions related to the topic logarithmic differentiation that we have discussed just now. You can try the question at home. And I think that's all for today. Stay safe everyone and stay healthy.